So we're gonna go through this as if it's an exam. So we're not gonna go through the theory because your teachers already taught you the theory portion. I'm just gonna help you like find a strategy on how to answer the questions. So let me just do this. Let me open WordPad so I can just have something to write on this side. So let me hide the ribbon. So yeah, let me adjust the size of this. So this is the November 2018 question paper. We're gonna go through this. Question 2, 3, and 4, possibly. If we can go through question 4, I'll start up another meeting. Hopefully it's not as difficult as it was joining this meeting, but I guess I'll be with you guys from now until we finish question 4. So the first question, it's question 2. They say a baby leaves a bowl of food on the floor and crawls eastward to fetch a toy that is placed 5 meters away. At the same time, a dog walks eastward towards the baby. It takes the baby 30 seconds to reach the toy, and the dog walks past the toy to eat the baby's food bowl. So just from this, you should know that you should be able to know that the baby is gonna travel this 5 meters in 30 seconds, just from the information that you've been given above. 30 seconds. So you have the time and you have the displacement. So now we're gonna go to the next question. They say, what is displacement? Oh yeah. So you know that the baby is gonna take 30 seconds to reach this toy. And now you also have to determine the displacement of the dog in order to reach the baby bowl, the food bowl. So that's gonna be 7 plus 5. I think that's 12 meters. So at least the very first thing you must do when you reach like a question, you should be able to like find all the information that you're gonna use. And in this particular case, you have to know how far the dog is gonna walk to reach the bowl, and you know how long it takes the baby to reach the toy. So they say determine the position of the dog relative to the baby before they both moved. So as you can see, the baby is at the football and the dog is here. So when they say determine the position, it's like you already know that the baby is 12 meters away from the dog. So that's basically gonna be a position. If you were to draw a vector diagram, the baby will be 12 meters away from the dog. So that's the position. And they say calculate the average velocity of the baby. So as you can see, the baby is gonna take 30 seconds to reach the toy. And you know that your average velocity, V average, is gonna be equal to the displacement divided by the change in time. So in this case, the baby is gonna walk, sort of crawl 5 meters, and that means your displacement is gonna be 5. If you want to use the initial and final equation, you can say your displacement is gonna be 5 minus 0, but it's really not that necessary in this particular case. And the time it takes is 30 seconds. Let me just get my calculator real quick. So the average velocity of the baby is gonna be 5/30. That's gonna be 0.17 meters. Meters per second. So Hendrix, were you able to get that?
So I got that answer, but I wrote west. I don't know if you must write like the
Oh, yeah, you
direction.
also have to write the direction because here it's 4 marks. So it's gonna be 1 mark for your equation, a mark for substitution, a mark for your final answer, and a mark for the SI unit and direction. So yeah, you can say to the west or westward, whichever you prefer. So I'm just gonna write west.
But you can, like, instead of saying west, you can also say to the right or to the left, you know. Is that still fine? Or no?
In this particular case, since just like by human nature, you know that west is left and east is right. So, and north is up, south is down. So I prefer that to be safe, you should use the one that they gave you, because they even gave you the plane here. Sorry, a compass. So you can say to the left, but in order to be most safe, so if you have a strict teacher that's gonna be marking your test, you should use the one that they provided to you. But if you know that your teacher is more lenient, then it's fine. So, do you have a question?
No.
Okay, so they say if the average speed of the dog is twice that of the baby, calculate how long it's gonna take the dog to reach the food bowl from the moment the dog started moving. So they say the average speed of the dog is 2 times. So the speed of the dog, I think it's 4 marks because first you have to show that you're calculating the speed of the dog. So the speed of the dog, the speed is gonna be equal to, I'm just gonna write D dog here as a subscript, So it's gonna be 2 into 0.17. And that's gonna be, I think it's gonna be 0.34 meters per second. So now that you have the speed of the dog, you have to they say they want you to calculate the time. So you can use your average velocity equation. And since I remember that you guys said you prefer to substitute first, I'm gonna substitute first instead of manipulating the equation to make time the subject of the formula. So you always have to write this original equation whenever they ask you to calculate. So you always have to write the initial equation, which is going to be delta x divided by delta t, because you can't just straight up start substituting. You're gonna lose marks in that way. So this is gonna be, let me undo that. This means 0.34 is equal to your displacement. In this case, is going to be 12 meters because it's 7 plus 5. So 12 divided by the change in time. So what you can do is either you can divide both sides by 12. Or some of you might prefer to like cross multiply them first, and you're still gonna end up dividing both sides by 12. So if you divide by 12, this is gonna cancel that. And here you're gonna divide by 12 also. Let me just undo that. I'm just gonna put it in the form of a fraction. So on this side, you're gonna have 1 over t. So in order to change this, you're just gonna take the change, you're gonna take this and put it up here, and take this and put it down there. That means you're gonna do the same on this side. This is gonna go down, and this is gonna go up. So you're gonna end up with delta t is equal to 12 over 0.34. Which is gonna be 35 0.29 seconds. So far, do you guys understand? Or maybe I should have used cross multiplication.
So I used cross multiplication and got the same answer. So
Yeah, that's why I'm saying like the way I did it, it might be a bit more confusing. That's why I'm asking, maybe I should have just used cross multiplication instead of like going this route. But do you understand how it's done?
yes, sir.
Trevor, on your side.
Yeah, I understand.
So that's the end of question 2. So do you have any issues with it?
Nope.
So
No.
basically in this question, you're only required to use the velocity equation. And sometimes they might give you a question where you have to calculate the displacement. I don't think it's gonna be that difficult when you have the time and velocity. So we're just gonna go to the next question, which is question 3. So on question 3, you have a diagram showing the position of an athlete at different time intervals. Sorry, let me just do something real quick. Sorry, my nose was blocked. So you can see that this athlete was able to travel 3 meters in 1.5 seconds, another 3 meters in 1.5 seconds, but then now he starts sprinting a bit faster. He covered 6 meters in 1.5 seconds, and then ran another 9 meters in 1.5 seconds. So basically it's 1.5 seconds, and from the way he's running, you can see that he started off at a constant velocity and is now accelerating because he's covering a greater distance at each time interval. So do you understand that? Because I'm pretty sure you guys remember, I think me and Trevor, we did this in class, right? During that Tika Timer project.
Yeah, we did this, like an
Yeah,
example of this.
so Hendrix, are you aware of like how to
So
determine
can you
whether
explain it,
someone is
please?
accelerating or decelerating
Can
on
you explain the difference between uniform velocity and uniform acceleration, sir?
sorry?
So can you explain the difference between uniform velocity and uniform acceleration?
Okay, so uniform velocity, right? That's constant velocity. That means you're covering the same distance in the same amount of time at each point. So let's say you're running, and every minute as you run, you run, let's say 30 meters on every minute. So that means on your first minute, you ran 30 meters. On your second minute, you ran 30 meters. Third minute, 30 meters. So the distance that you cover in every time interval is going to be the same. Do you understand that?
Yes, sir.
So when you're uniformly accelerating, it's the same picture. You're running, but this time, let's say you're accelerating at 2 meters per second, right? So that means at the first minute, you'll cover 2 meters. But on the second minute, you're gonna cover 4 meters. So you're adding that 2 meters. And at the third minute, you're gonna cover 6. The fourth one, it's 8. You cover 8 meters. So you're uniformly accelerating because you're adding the same distance as you run, because it's gonna be like the first, let's just use seconds. The first second, the second second, third second, fourth second. And now what we're looking at here is the displacement and the velocity in a way. So basically, let me just say delta x. So here it's gonna be constant velocity, and here it's gonna be constant speed. Sorry, constant acceleration. So we're gonna look at the displacement. But if you also want, we can also look at the velocity, how the velocity is affected when you're running at constant velocity and constant speed. We can also look at the change in velocity if you want. So just to make this clear for you, this is displacement. It's not like the position where you are, unlike in this diagram, because in this diagram it's based on the position. But here we're gonna talk about displacement, right?
Yes, sir.
So let's say you're running a constant velocity of 1 meter, 2 meters per second, right? So at the first second, you ran 2 meters. If your velocity is constant, at the second second, you're also gonna run 2 meters. Third one, 2 meters. Fourth one, 2 meters. So I think we can also try to relate them down here. You end up covering 8 meters in 4 seconds. So here we're just gonna have the total. So remember, at constant velocity, there is no change in velocity. That's why I did not add this part here. Your change in velocity is always gonna be 0 since you're running at a constant velocity, because this is gonna be an initial and this is gonna be a final. So it's gonna be 2 minus 2, that's gonna be 0. Now a constant acceleration, let's say you're accelerating at 2 meters per second squared. Per second squared. So what's gonna happen is that on your first second, you will cover 2 meters. But on the second one, since you've already accelerated, you're gonna cover 4 meters. On the third one, you're gonna cover 6. On the fourth one, you're gonna cover 8. As you can see here, the displacement stays the same. It's always 2. But here, you're adding. You're still gonna add 2. So it's like the first one, you add 2. The second one, you add 2. The third one, you're gonna add 2. You see?
Yes, sir.
So I'm not sure if that's a good explanation, but that's gonna be the same here. It's still gonna be like 2, 4, 6, 8. So in a way, you covered 10. You already covered like 20 meters. So, do you understand it?
Wait, sir, why is the change in velocity not 2?
Oh yeah, I'm sorry. Yeah, the change in velocity is gonna be 2. I'm sorry about that. It's just the change in displacement. That's bright. That's very nice. So yeah. Yeah. Thank you for that. I didn't even notice that, So you can see you add 2, you add 2, you add 2. So, but I think if you're able to figure out like the change in velocity has to be 2, I think you understand how constant acceleration works.
Yes, sir.
So we can move on.
Yep.
I think I'm gonna be able to do. I think I'm gonna be able to do question 3.2, and I'm gonna have to restart the meeting. I just hope it's not as bad as it was last time, but I think I got the hang of it. So yeah. So we're gonna go to question 2, and they say, what type of motion? They want you to say motion in uniform velocity or motion in uniform acceleration is represented by A to B. So as I've already told you, in A to B, this is uniform velocity because you can see he covers 3 meters every 1.5 seconds. So you can say that the velocity is constant. But when it comes to from B to C, this is uniform acceleration because he covered 3 meters here, and now he's covering 6. So you add 3 onto 3, it's gonna be 6 meters, and now you add another 3 onto 6, it's gonna be 9 meters, and you add another 3, it's gonna be 12 meters. Because this is 3 meters, there's a 3 meter difference here, there's a 6 meter difference here, there's a 9 meter difference here, and there's a 12 meter difference here. So you can see that at every position, the athlete is able to cover 3 more meters at every time interval. So A to B, that's gonna be uniform velocity. That's A to B. And B to C, that's gonna be uniform acceleration. So they say use the information to draw an acceleration versus time graph on the graph paper. So since they want you to draw an acceleration versus time graph. I think I'll be able to just draw that for you in a few seconds. So I'm pretty sure I gave you guys a few pointers last week on how to draw a graph. Do you remember?
Wait, so it's a position versus time graph.
Accelerate position versus time graph. Okay. So do you remember how to draw it? I think I told you I told you guys how to draw it last week.
Yes, sir.
So what's the first thing? Because I think I gave you like a few pointers on what's required in order for you to get all the marks. So do you remember like what's the first thing?
The headings, the actual graph and the numbering and stuff. And the scale.
Yeah, the scale is sometimes important. So the first thing is the heading. So you're correct. So I'm just gonna be like accelerate position versus time graph. Or you can just say graph showing the accelerate position versus time. So what's the next thing?
The headings on the axis, sir.
Okay. So the headings on the axis. So time is always gonna be on this side, and the other side. Why can't I make this text? Okay, let me try this again. I'm just gonna write it here. I'm just gonna say X position. Okay, from this graph, what else do you think it's missing?
The
So the
numbering.
unit.
Now, except for that, before you get to that, what else?
So the it doesn't have the units by the axis headings.
Okay. You see, that's why like I'm just asking so I can just see whether you guys still remember. So this is gonna be position, that's gonna be in meters, and time, that's gonna be in seconds. And what else? Remember, this is a very simple one that I've been trying to show you guys. You have to label your axis. Show that this is the x-axis and this is the y-axis. So since it's saying less than a minute left, I'm just gonna end it here and we'll start another one.